Okay, so now we're going to be solving exponential equations, but now the variables are in the base. That's when it's called an exponential equation. The ones that you did yesterday and you did very well with were power equations. That's when the base has the variable. Now the variable is in the exponent. So I hope you tried the do now before looking at this, but here you see that they have a power 5 to the x plus 1 equal to another power 5 to the 4 power, both of them having the same base as 5. So if the bases are the same, I hope it makes sense to you, then the exponents would have to be the same. So this would just then become x plus 1 equals 4. When the bases are the same, you could just drop the bases and set the exponents equal to each other. So you just subtract 1 from both sides and you'd get x equals 3. Final answer. Okay, so the first group of practice problems, all the bases are the same. Number 1, I mean, this rarely happens that the bases are the same, but if you're in a situation like that, you need to understand that you would just drop the bases and then set the exponents equal to each other. Minus 2 on both sides, get x equals 1. Number 2, they're both 3 as the bases. So if the bases are equal, I could drop them and just set the exponents equal. So here it's a linear equation where variables on both sides. So you have to remember basic algebra to minus x on both sides and get x plus 1 equals 2. Then you could minus 1 on both sides and get x equals 1. Again, number 3, again, has the bases the same, 3, so then the exponents would have to be the same. X squared would have to equal 2x minus 1. So that's a little trickier. Do you recognize the fact that since there's an x squared here, this is a quadratic equation, so I have to get it set equal to 0. So I'll subtract 2x on both sides and add 1 on both sides. And then once you have a quadratic equation equal to 0, I have to factor. Here I'll use add multiply and get that it would be x minus 1 times x minus 1 equals 0. And then get that x minus 1 equals 0. The other factor is the same, so we're only going to get one solution that x equals positive 1. Okay, so that's if you have an x squared. I don't think any of the other examples today are going to have that, but that could show up. Okay, so to solve, if the bases are the same, it's very easy. You drop the bases and set the exponents equal, and then solve the equation. That's what we just did for examples that do now 1 through 3. If the bases are not the same, which is your more often situation, you have to rewrite the larger base as a power of the smaller base. Multiply the inside and outside powers, which is your power to power rule. And then use the steps for the easier ones. After you do this, step 1 and 2, then you drop the bases and set the exponents equal and solve the equations. So there's just this additional 2 steps. So before you could prepare to rewrite powers, I first want to discuss powers with all these bases. If you have a 2, a base of 2 rather, you could use a base of 2 to write the following powers. If it's 2 to the first power, it would be 2. 2 to the second power, 4. 2 to the third power is 8. 2 to the fourth power is 16. 2 to the fifth power is 32. So you could generate this list to have in front of you every time you're doing exponential equations. Have your power list. And you don't have to memorize it. I'm simply just raising these numbers to each power. So when I'm getting the powers of 3, first I'm going to say what's 3 to the first power? 3. 3 to the second power, 9. So you just keep multiplying by the base one more time. 3 to the third power, I have to take 9 and times it by 3 one more time. 3 to the fourth power, I'm going to take 27 and multiply by 3 one more time and get 81, and so on. I don't memorize these numbers. I'm just generating it as I'm saying it. 4, powers of 4. 4 to the first power is 4. 4 to the second power is 16. 4 to the third power, 16 times 3 is 64. 4 to the fourth power, I believe, is 256. So the numbers start getting really big. These are exponential equations now. Exponential equations get big exponentially. Big. Fast, rather. 5 to the first power is 5. 5 to the second power is 25. 5 to the third power is 125. Just keep multiplying by 5. If I take 125 and multiply by 5 one more time, 5 to the fourth power is 625. Okay. 6 to the first power, 6. 6 to the second power, 36. 6 to the third power is 216, and so on. 7 to the first power, 7. 7 to the second power is 49. 7 to the third power, if I multiply this by 7 one more time, I get 63, and then 28 plus 6 is 343. That's right. That sounds familiar. Sorry. So there's my powers of 7. I could keep going. 7 to the fourth power, and so on. 8 to the first power is 8. 8 to the second power is 64. Times 64 by 8, get 8 to the third power. I don't have that memorized, so I'm just going to do dot, dot, dot. 9 to the first power. 9 to the second power. 9 to the third power. What's 81 times 9 is 729. So that's 9 to the third power. And then 10 to the first power is 10. 10 to the second power, 100. 10 to the third power, 1,000. So raising 10 to the powers is easier, like when you did scientific notation back in 8th grade. The number of zeros is just equal to the exponent. So these are your powers. This is something that you're going to want to look back to as you're doing the problems. So now the first two samples, I'm going to be able to look at the powers as I'm doing it. Now notice that in number 1, the powers aren't the same. I have a power of 4 and a power of 2. Or in number 2, I have a power with a base of 5 and a base of 25. So you need to get the powers the same. Sorry, the bases the same. So I take the larger base. So for number 1, the larger base is 4. And I want to have an equal base with the smaller base, which is 2. So could I rewrite 4 as a power 2? I'm going to look at my powers of 2, and I can. 4 is the same thing as 4 to the second power. So I'm going to rewrite the base of 4. Instead of 4, do you all see that 4 is the same thing as 2 squared? And then I'm just going to bring down that exponent that was there, x, equals 2 to the 3x plus 1. The next step is using the power to power rule. So I keep the base and I multiply the inside and outside power. 2 times x is 2x. Then I could bring down the other side because that's enough to have common bases. So today's example, I'm only going to have to change one of them. On Monday and Tuesday, it will get more difficult. We'll spend a few days on this because it's important. So now, after that step, now the bases are the same. They both have a base of 2, so I could drop the base and set the exponents equal to each other. And now I solve that equation. There's variables on both sides, so I'm going to minus the 3x on both sides. Get that negative 1x is equal to 1. Divide by negative 1 on each side. And get that x is equal to negative 1. Final answer. You can plug it in and check in your calculator. The next one, again, the bases aren't the same. So I'm going to take the smaller exponent, I'm going to take the larger exponent and write it with a base of the same as the smaller. Could we write 25 as a power of 5? Sure we can. Look at the list of the powers of 5. 5 to the first power is 5. 5 to the second power is 25. So 25 could be rewritten as a power of 5. So I'm going to bring down the power with the smaller base down. The larger base, the 25, is going to be replaced. So you're always replacing the larger base. 5 squared. Do we all see that 5 squared is the same thing as 25? And then we bring down that x plus 2 that was there. So the 5 to the 5x plus 1 is going to come down. The second one, 5, we're going to use power to power, so I'm going to multiply 2 by x plus 2. In this case, we're going to have to distribute and get 2x plus 4. And now I could drop the bases because they're the same and reach 5x plus 1 is equal to 2x plus 4. So we have a first degree equation, variables on both sides. I'm going to minus the 2x on both sides. Get 3x plus 1 equals 4. Minus 1 on both sides. Get 3x is equal to 3. Divide both sides by 3. And get that x is equal to 1. Okay, a couple more before you're going to try on your own. So the next two, again, the bases aren't the same. So here, the larger base is 16. Could we rewrite that as a power of 4? Sure we can. 16 is simply 4 to the second power. Then I'm going to bring down the x minus 3 equals, and then the 4x to the x minus 3 is going to come down. So I'm realizing all my examples, the base is being rewritten as the second power. It's not only just the second power. Sometimes the bigger base will be the smaller base to the third power, the fourth power. So you have to look at those lists of powers up here and see how you could rewrite the numbers. All right. So here I'm going to bring down the base of 4, multiply the inside and outside powers, which require us to distribute again. 2x minus 6 equals the 4 to the x minus 3. And then once the bases are the same, I'm going to drop them and set the exponents equal to each other. And then I could minus x on both sides, get x minus 6 equals negative 3. Add 6 to both sides, get x equals positive 3. And lastly, when it's a base of 10, looks like a big number, but it actually makes it easier. 100 has 2 zeros, so that's the same thing as 10 to the second power. And then I'll bring down the x plus 2 that was there. And the first side already had a base of 10. So in today's example, only the larger base had to be changed, not the smaller one also. They get harder where they both need to be changed. So here the first one's going to be brought down. The second one I have to multiply the inside and outside powers. So I'm going to distribute and get 2x plus 4. Once the bases are the same, I could drop them and get 3x equals 2x plus 4. Minus the 2x on both sides, and then I'm finished because that means x is equal to 4. So now I have 3 for you to try on your own. Okay, the first two are going to be very similar. Number 7, you might have to think a little bit more. Okay, please contact me with any questions. You did awesome yesterday. Good luck and have a wonderful weekend.